Alright, so here we've got a particle moving with velocity v in a medium where resistance to motion is proportional to velocity. This is the one that's often used because we can actually split it up into horizontal and vertical components, whereas our quadratic drag is much more difficult. You can't just split it up simply like this one. So anyway, let's look at this one first. So R equals minus kV. So the resistance here is proportional to the velocity. It's proportional to the velocity. So if we think about using trig, and we've kind of done it in here, so pay attention to this to start with. So here's our resistance, which is proportional to velocity. So we've got a negative k there, and we're just going to make the angle that it's on alpha. We're not given that, but let's make it alpha. So in that case, the vertical, we know already that the horizontal velocity is cos alpha of the velocity in the direction it's going, and the vertical velocity, that dot, is sine alpha lots of the velocity on that original vector. Alright, so if we look at the resistance in the horizontal plane, so remember resistance is proportional by the minus k, proportional to the velocity. So what is the velocity in the horizontal plane? It is v cos alpha lots of v. Alright, so if we have a look, it's really nice, you can do this with linear. So we can make it minus k, and then we can just put x dot. That is the horizontal velocity. And in the same way in the vertical plane, we've got minus k, it's proportional to the velocity by minus k, and the velocity that we've got in the vertical plane is v sine alpha. So again, we can go like that. So the components for resistance in the horizontal and vertical plane are minus k x dot and minus k y dot. That's just using trig. We could also use vectors, which they like doing because they've introduced vectors now. So here you can see I've got this vector with the resistance on it. So R equals minus kV. And what I could do is I could break the vector v up into its components. So if you think of vector v, it's we know that from our previous work, it's got this much in the I direction, so x dot in the I direction and y dot in the j direction, or the vertical direction. You can't see my i's and j's. And so if I pull those apart, we get this, and oops, it should be minus k, doesn't matter, minus k y dot in with a j vector there. So you can see from that as well that in the horizontal plane we've got minus k x dot, and in the vertical plane we've got minus k y dot. So they are the components. So it's quite nice for when we're dealing with linear drag, not so much when we're dealing with quadratic drag.